Hello, welcome to RF Insights. In this video, I want to quickly go over Monte-Carlo method for simulating radio frequency problems. Monte-Carlo method is basically a statistical analysis of the radio systems as compared to a deterministic approach. So, for example, a study of interference in the radio systems could be done in two separate ways: a deterministic approach and a random approach, or Monte-Carlo approach. This Monte-Carlo method is defined in ITUR SM.2028 and is a computational approach that uses repeated random sampling to estimate uncertain outcomes or solve complex problems that are difficult to solve deterministically. By simulating a system or process many times with random inputs, it generates a probability distribution of potential results. And this allows for a comprehensive understanding of the risk and possible future scenarios. This technique is named after the Monte-Carlo Casino in Monaco and is widely used in finance, physics, engineering, and project management for tasks like risk analysis and complex value estimation. The example I often give is assume that you want to count letter T in a 300-page book. The deterministic approach would be to read the whole book and just count the number, the letter T. It's an awful approach, but it gives the least error. Monte-Carlo approach would be choosing 50 pages randomly inside this book and counting the letter T in those 50 pages, and then expanding these results to the whole book instead of reading the whole book. It has an error, but it gives an overview of the solutions to our problem. Here you can see a problem of interference from a cluster of base station 5G towers into a satellite station. So these each of these towers here are paired with three mobile units that are moving around these stations randomly, and the emissions from this setup will create an interference in this satellite station, and we want to evaluate that. So one way of doing it is by Monte-Carlo method that we are going to explain here. The Monte-Carlo method would be equivalent to randomly moving these mobile units around in this setup. So here I want to show you how it works. So I have my setup here in the software, and I want to plot the I/N at the satellite station. Okay, so these units will be moving around randomly. So you can see here the units are moving around randomly, and you can see that I/N curve is plotted. The two red triangles that you see there are the protection criteria for our station. You can do it in an accelerated mode. So whenever it stops, you can have the results faster, and you can see the I/N curve here plotted for about 5 hours of operation of this IMT or terrestrial system setup. Here is another example of evaluating interference from a very widespread use of these stations on the shore or on the land, and we want to evaluate interference into this maritime ship or radar that's operating on this ship. So this is basically our non-GSO system constellation that you can see, and this is the deployment that you see on the land. So this is a very high altitude view of that. On the next slide you will see how how changing basically changing these oh, one thing I forgot to mention, that in our previous setup, the ship here, the ship location and the antenna orientation of the radar has been randomized using the Monte-Carlo method. So the ship is going to move randomly along a strip on the sea, and also it's the pointing of its antenna will be random as well. And using this randomization, we can get an overview of how interference behaves in this part of the sea. Okay, so now let's see how it works. So when I run the simulation, you can see the satellites moving around, and I over N on the ship is plotted here, and that's the ship that's moving around on the sea, right? So this randomization method makes things a lot easier for us. We don't need to do it the hard way, a deterministic approach, for example, recording or simulating the motion of a ship in a deterministic path. Instead of doing that, we just randomize its location in a desired area, and we can estimate the interference by doing so. So here you see some of the parameters, how the this one is the elevation angle of the satellite stations on the ground, how the elevation angle changes as the satellites move around. There are a lot of parameters that you can monitor here. That's it for this video. I hope you enjoyed this and you learned something new. If you have any questions about Monte-Carlo method, or any questions about the simulation of the radio systems, please let me know in the comments. And also please don't forget to like the channel and leave a comment and subscribe. I will come back again with more interesting videos on the subject of radio and RF engineering and simulations. Thank you very much and have a good time.